Okay, so in this video, I'm going to talk about standing wave and fundamental frequency. So yeah, let's talk about, what standing wave is. The first thing you have to understand is what is wave. And there are only two kinds of waves, basically. The one is transverse wave, which is, for example, sound. And another example is another kind of wave is longitudinal waves. Yeah, for example, this is light. And yeah, for example, like an ocean wave. And yeah, it is kind of complicated. The difference is complicated, but in both cases, the most important things is in both cases, the wave can be described as sine curve, or basically the idea is this type of wave. So this is all you need to remember. And when the waves of the same kind are overlapped, so overlap is the important keyword here. A wave can be mixed up. So this is important to understand what the standing wave is. So for example, this sentence means, for example, you have this type of wave, going in this direction. And when you have same waves but in a different direction like this, if you have these two waves in the same place, these waves are going to make this type of waves. And if you see so this is something you can see when you have two waves in a same place, which is very important idea about the standing waves. Because so first, when you talk about standing waves, you will hear a lot of words like node. And basically, the node is a fancy way of saying no motion point, no motion point. And if you see these waves, this is no motion point. So you can say that we see 1, 2, 3, 4, 5, 6, 7, 8 nodes in these waves. So this is how you use nodes. And the waves with a node is called standing waves. And so basically standing wave is one special waves that has a certain amount of nodes. And when node is just one, which is called the frequency, so which is called fundamental frequency. So this is the frequency when node equals to just one. And the frequency of standing wave depends on the tube ends. So now we call that this as a tube. And the frequency of the standing wave depend on the tube ends, which is open or closed. And of course, it depends on the length of the tube. And of course, the wavelength is important factor when you create the standing waves. So it's pretty simple. And when you actually solve a problem of the standing wave or fundamental frequency, there are only several things that you have to remember. So first is unit of frequency. So we usually use hertz as a unit of frequency, and which is equals to second just inverse. And another thing you have to remember is how to calculate the fundamental frequency. And like I said, the side of openness is important. For example, when one side is open and the other side is closed, the fundamental frequency can be calculated as F0 is usually the fundamental frequency, and this is calculated as V. This is the velocity of the wave divided by 4L. L is the length of the tube. But when you have both sides are open or closed, the fundamental frequency is going to be F0 velocity equal to L. So the condition of the sides open or closed is pretty important when you want to study the fundamental frequencies. But this is all you have to understand. So using this knowledge, let's solve our problem. So the problem is an open tube has a fundamental frequency of 30 Hertz. The speed of the sound is 300 meters per second. If cut the tube in half and close one end, what will be the new fundamental frequency? So the original fundamental frequency, F0, let's say original, equals to, this one is both are open tube. So remember that this is what you have. And you can basically use sorry. My setting is here we go. So the V equals to 2L, which is 30 Hertz. And now we don't know the length, so let's calculate this L. So L is basically you're gonna move this to here and F0 to here. So L can be calculated as V divided by 2F0. And V is 300 meters. And F0 is 30 Hertz. So the L is going to be 5 meters. And now you cut into half. So L new is going to be 2.5 meters. And now you only close the one end. So the new way to calculate the fundamental frequency is going to be this one. F0 equals to V divided by 4L instead of like 2L. And the V is not changed, so this is going to be 300. And 4, and the new L is going to be 2.5. So this new fundamental frequency is going to be 30 Hertz. So it's important that even if you cut the tube into half, if you closed one end, because the used equation are going to be different, like as a result, you can have like same fundamental frequency. This is how important the the openness condition of tube. So this is only things that you have to be careful for when you're solving a problem set. So please be careful about this, and I hope this was helpful. And just let me know if you have any question in the comments. Bye.